the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. Now, this video you're about to see is one of my older videos. The quality is not the same as my new video series. My intent is to make a newer version of this video at some point in the future. However, I want to make sure that students currently using my Mathematics in Review video series have access to as much help as possible when it comes to prerequisite topics. With that being said, let's get started.
Now we're going to go ahead and start this section with a simple definition of an algebraic equation. Algebraic equation is essentially a combination of variables and constants with operations and an equal sign. And this is an important part, that we also have an equal sign. There's actually a very easy way to think of algebraic equations other than just the fact that, for example, anything of the form like 3x is equal to 12 or pi times x minus x squared is equal to 3y plus 1. These are both equations because they have equal signs, they have variables, they have numbers, and they have operations. Addition, multiplication, squaring, all that stuff, those are all considered operations. However, it also turns out that algebraic equations are essentially statements that are either true or not true. They're essentially the mathematical equivalent of a claim that somebody makes, like in English. Somebody who's just speaking with spoken language instead of mathematics would say something like, I have $300, or the amount that I have in my wallet is $300. That's either true or not true. That person's name is Bob. That's either true or not true. That can be proven or disproven. You can just ask the person if their name is Bob. So those type of statements are the mathematical or the English equivalent of an equation. And so I wrote a couple of them out. His name is Bob. That can be proven or disproven. We are eating Oreos, something like that, right? That's something you can prove or disprove. However, expressions are very much different beasts. And easiest way to see expressions in language versus what we do in mathematics. Mathematics, an expression is like 3x. It's neither true or untrue, it just is. So an expression in English is like hi, or blue, or wow. These are things that you state, but it's not like somebody says, oh, that person said wow. I wonder if that's true or not true. You can't, I mean, there's no truth or untruth to it. It just is what it is. So equations, the language equivalent, are things that can be proven or disproven, and expressions, the language equivalent, are things that just are. So the idea behind equations is to solve them, to find out what the unknown is, essentially to prove something about that. We are eating Oreos, so let's go ahead and prove that. You know that so we look around for the bag of Oreos, they're empty, and somebody has chocolate in their teeth. That pretty much is an indication. So let's go ahead and take a look at a little sub-example I have here. What can we say that is common about the following equations? So we have equations 1, 2, and 3 here. And they're all different equations. They all look different. The last one, it tells us explicitly what x is here. X is 2. The second one doesn't tell us explicitly what x is. However, if you look at that, if x were 2, it'd be 2 times 6, or 12 on the left-hand side, which would make this a true statement. Along the same lines, actually, the first one, if we were to let x equal 2, I always do my math with a question mark and the equal sign because I think, just because it makes it clear that we don't know if these two sides are equal yet. That would be 10 minus 8, which is 2. And on the right-hand side, negative 2 plus 4 is 2. Oh, which is a true statement. What these three equations have in common is they all have 2 as a solution. And in fact, they all have x equals 2 as a solution. Often, by the way, in mathematics, people will say solve this equation. They won't say solve for x or solve for y. They'll just say solve this equation. If they're asking you to solve an equation, it's implied it's for the only variable that's in that equation. If there are 2 variables, then you need to ask them, what variable do you want me to solve for? But anyway, back to this. They all have x equals 2 as a solution. Well, if they all have the same solution, we could say that they're kind of from the same family. they have the same set of genes or DNA, I suppose, because they all have the same, well, solutions. So let's go ahead and define what that means. These are all called equivalent equations. And what are equivalent equations? Equivalent equations are equations, and you see my shorthand, EQNS means equations to me, having the same solution. And maybe I'll even be more specific here. I'll say having the same solution set. Those would be considered equivalent equations. So if I go back to that previous example, while these all have the same, or because they all have the same solution, x equals 2, these are all equivalent equations. And as I mentioned before, I consider them to be of the same, like, genetic code. They're born of the same species or whatever. In this one right here, so first thing we do is clean up both sides. I'm not going to write that step down. I'm just going to do it. And this implies when we combine like terms on each side, we'll have a single x minus 2 is equal to a single x plus 20. And then, before we can start untying the knot, we need to get all our variables on one side. Well, I'm going to go ahead and subtract this x from both sides. And we get the following. X minus x, that's gone. X minus x, that's gone. A lot of people, by the way, I've noticed this written, they think that there should be an x, so they write 1x over here. X minus x is nothing, and the x minus x over here is nothing. So you get to negative 2 is equal to 20, and you ask yourself, is that true? You should always stop every single step. You should just pause for a moment and say, can I go any further, or is that true? That cannot be true. So every once in a while, we'll get an equation somebody gives to us, and it just can't be, there's no possible way it could be true. This is called a contradiction. In mathematics, we often call an equation with no solution, or an equation that reaches some type of logical issue like this, a contradiction. And this is the equivalent of saying to somebody, I am a fish. The fact is, I'm not a fish, right? So that is not a true statement. I could say, I am a person, or I am a human, or, I have brown eyes, or something like that. Those are true statements. Somebody could prove it. But this can't be proven because it's not true. So it's a contradiction. Sometimes you'll get stuff like this, solve that. And when you do try to solve that, you'll get all the way down to x minus 2 is equal to x minus 2. You'll subtract x from both sides, and you'll get negative 2 is equal to negative 2. And that is always true. That gets a special name as well. If something is always true, we call that an identity. So just to let you know that when you're solving things in mathematics, if you get to a statement where a constant is equal to a constant, and they're not the same number, like this one over on the left, you know that's not true. It's a contradiction. But if, on the other hand, when you solve an equation, all variables end up disappearing and you get a constant equals a constant and they're the same number, like negative 2 is equal to negative 2, that's always true. We call that an identity.
Thank you for watching this review video. As I mentioned previously, it's an older video that will eventually be updated. However, it should get the job done for you. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar, or if it was confusing to you, then I recommend you review any prerequisite material mentioned in the video. If you find you're continually having to research the prereq material here, you might want to consider speaking to your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.